Hello friends, this is the Westcoast Math Tutor. Today we are going to learn what exponential growth functions and exponential decay functions are. The function f of x equals b raised to the power of x, where b is greater than 1, is the parent function for the family of exponential growth functions. And the same function, where b is between 0 and 1, is the parent function for the family of exponential decay functions. When b is greater than 1, the graph rises from left to right. And when b is between 0 and 1, the graph falls from left to right. Both graphs pass through the y-intercept 1, and the x-axis is the asymptote for both graphs. It's important to see immediately whether a function represents exponential growth or exponential decay. So let's look at the functions y equals 3 raised to the power of x, y equals 1/2 raised to the power of x, f of x equals 0.75 raised to the power of x, and f of x equals 2.5 raised to the power of x. Which of these functions represent exponential growth and which of them represent exponential decay? Feel free to pause the video and write your answer in the comments. Some real-life quantities increase or decrease by a fixed percent each year or some other time period. The amount y of such a quantity after t years can be modeled by y equals a times 1 plus r in parentheses raised to the power of t, which is the exponential growth model, and by y equals a times 1 minus r in parentheses raised to the power of t, which is the exponential decay model. Note that a is the initial amount, and r is the percent increase or percent decrease, written as a decimal. 1 plus r is the growth factor, and 1 minus r is the decay factor. Let's look at two examples to make this clear. The value of a car y can be approximated by the model y equals 35,000 times 0.75 raised to the power of t, where t is the number of years since the car was new. Now, how can we tell whether the model represents exponential growth or exponential decay? That's simple. The only thing we have to check is the base, which is 0.75, which is greater than 0 and less than 1. So the model represents exponential decay. Next question. What is the annual percent decrease in the value of the car? Because t is given in years and the decay factor is 0.75, which is 1 minus 0.25, the annual percent decrease is 0.25 or 25%. And the last question is to estimate when the value of the car will be $10,000. We plug in 10,000 for y. Divide both sides by 35,000. So we get 10 over 35 equals 0.75 raised to the power of t. And after taking the ln on both sides and bringing down the exponent t, using the power rule, we get ln of 10 over 35 equals t times ln of 0.75. And after dividing both sides by ln of 0.75, we get t equals ln of 10 over 35 over ln of 0.75, which is then approximately 4.4. So after approximately 4.4 years, the value of the car will be about $10,000. Let's do an example with an exponential growth model. Let's say in 2000, the world population was about 6 billion. During the next 23 years, the world population increased by about 2% each year. Write an exponential growth model giving the population y in billions t years after 2000. The exponential growth model which we are going to use is y equals a times 1 plus r in parentheses raised to the power of t, where the initial amount a is 6, and the percent increase is 0.02 because 2 divided by 100 equals 0.02. So the exponential growth model is y equals 6 times 1.02 raised to the power of t. How can we estimate the world population in 2010? Using this model, we can estimate the world population by plugging in t equals 10, because 2010 minus 2000 equals 10. So we get y equals 6 times 1.02 raised to the power of 10, which is approximately 6.12 billion. Let's ask one last question. How can we estimate the year when the world population was 7 billion? That's simple. We plug in 7 for y and solve for t. After dividing by 6 on both sides, we get 7 over 6 equals 1.02 raised to the power of t. And after taking the ln on both sides and bringing down the exponent t, using the power rule, gives us ln of 7 over 6 equals t times ln of 1.02. And after dividing by ln of 1.02 on both sides, we get approximately 8. So the world population was about 7 billion in 2008. This video is what I did for you. If you want to do something for me, hit the bell button, like, share and subscribe. Thanks for watching and happy learning, everyone.